Constant speed is what we're going to look at today. So we're going to use ratios to work with how fast things move. Our ICANs are, I can create double number line diagrams to help me reason about constant speed, and I can decide which two objects is moving faster based on the amount of based on the information about the distances they travel and the amounts of time. Okay, so make sure you have your ICANs, today's date, and you're ready to move on. Before we get into that, let's look at dividing by powers of 10. See if we can do these in our heads real quick. So, think. 30 divided by 10 is going to be 3, right? 34 divided by 10, it's going to be 3 4/10, right? Because all those digits are going to move down one place value, powers of 10. What about 3 4/10 divided by 10? 34 hundredths. What about 34 divided by 100? It's going to actually be the same thing as the one above it, isn't it? Because here we're only moving everything one place value smaller. We're dividing by 10. Remember that when you go from one place value to the next, that's by either multiplying or dividing by 10. Well, if we're going to divide by 10, both of these digits have to go down one place in value. Here we're dividing by 100, which is 10 times 10. So these have to move two place values smaller. So this 3 in the whole or in the tens place ends up in the tenths place. And this 4 that was in the ones ends up dropping back into the hundredths place. Being able to mentally move things by multiplying and dividing by 10, certainly a good skill to make sure that you keep fresh all the time. Okay, part of the reason why we would do that is if we were back in the classroom, we'd be able to do where we could move in a straight line and actually be able to see some rates, some distance versus time. Now, in 5th grade science, you would have talked about distance versus time graphs, which is similar to what we're talking about with the ratios and such. So to kind of help visualize what we're going to talk about here, we are going to use a website, and I'll put the link for you to look at as well. But basically looking at rates of speed, how fast something moves in a particular time. Okay, so I've got a little character here, and I'm going to make him move a little bit. Now, if I look at this, I've got distance on my y-axis, and I've got time on my x-axis, remember from graphing. It looks as though that time keeps going, but it doesn't look like he changes his distance very much. So I'm going to just kind of hold him there. Pretty simple, right? This one is one of those where we really get just a quick little ratio. We get really 0 increments in however many seconds, right? We're in a total of 14 seconds. Really doesn't matter what we have there, does it? Let's take a look at this one. So here, we need to make it so that it stops or that it stays on this constant speed. And we know it's a constant speed because it's one straight line and it doesn't change pointing up more or pointing down more. So I really just want to keep it at the same constant speed the entire time. Okay. Now, unfortunately, I didn't do very good at matching the line, because if I had done a really good job of matching the line, it looks like 1 second, I wouldn't be at a whole number here. But it looks after 2 seconds, I should have been really close to 1 unit away. A little bit more than that, And actually, it looks like that it's not a one unit of distance every 2 seconds. It actually looks like looks like 5 crosses my line here. So this is one. Looks like it was a ratio of every 2 increments in 5 seconds. And if that's true, then it should have kept that same thing all the way across here. The next one should have been at 4, a distance of 4, should have taken 10 seconds. Well, here's 10 seconds. And here's up at 4. It's a little bit off from that, isn't it? Really, the entire thing goes all the way over to 14. And it matches up with line 6. So it's actually a 6 to 14 ratio, which isn't too far from what this would be, right? Because the closest this should be is, let's see, to get 6, I would have that times 3. So if it was a 2 to 5 ratio, it would have been 6 to 15, wouldn't it? And actually, since it's not, and it's a 6 to 14, I could divide both those by 2 and get what? Yeah, it's actually a 3 to 7 ratio as far as it moves. So let's check that out. So at 7 seconds, it should be exactly at, hey, there it is, exactly right at 3 seconds. So my earlier statement of a distance of 2 after 5 seconds wasn't far off, but looking at the entire thing, we can see that it is exactly here. This one, obviously, there's going to be a point where it stops, but if we look at this moving part here, is that the same rate as this one before it? Remember that this was at a 3 to 7 ratio. So if we go to 3, and if we go to 7, so we go 7 for the time, and we go up 3, how is this going to compare? Well, if our previous one was a 3 to 7 ratio, this one's not the same because it looks like that this one goes, yeah, for every 1 unit of distance, it takes 1 second to go there. So this one's actually at a 1 to 1 ratio. So should on this puzzle, should it be end up moving faster than it was on the previous puzzle? Yeah, actually it is moving faster because this is going to go that unit 3 distance actually just takes 3 seconds. Whereas before, to go a 3 units distance, it took 7 seconds. Okay, let's try it real quick. Yeah, and I've got to drag the little character a lot faster to end up making that rate here at the beginning part on how fast it moved. If we kept it going at that speed, it would have been well off the chart for what this can show, okay? So with what we were talking about before, our moving slower one, remember we had a 3 to 7 ratio, right? I'm going to change this to 14. Okay, and our other one actually was a 1 to 1 ratio. Hang on. Okay, so we know that on the second one, we had a 1 to 1 ratio. Now I've got all my marks lined up here, but are they all going to be exactly the same? No, distance-wise, we've got that the same. At 7, using that other one would have got there in 7 seconds. And I've got this backwards, don't I? Yep. All right. Now I could go back and find the parts of how far it went, but I don't need to, because really we're only looking at whole numbers here. Here my lines are exactly the same for both the lines because we're moving at a 1 to 1 ratio. Here we're going a lot less distance in the same amount of time. So we can clearly see that here we've got a 1-to-1 ratio when we're going faster. Here we've got a 3-to-7 ratio, or a 6-to-14, and that's going to be clearly longer than it was in going with the faster speed. I would hope that you already know this, but that you have this rate of speed down somewhere in your past, but meters per second is a unit of measuring speed. You're probably more familiar with miles per hour. So it's just a unit of speed. It's some distance per every unit of time, and that's how you get speed. All right, so speed is always distance per amount of time. All right, quick little one for you to try and figure out here. There are 4 questions. We got Lynn and Diego both running for 10 seconds, each at a constant speed. Lynn ran 40 meters in 10 seconds. Diego ran 55. Who's going faster? Yeah, it's going to be Diego going faster because in the same amount of time, he's going a greater distance. Let me prove it. For Lynn, we know that she goes 10 seconds goes 40 meters. Well, Diego ran 55 in the same amount of time. If we put those down to 1-to-1 ratios, Lynn goes 1 meter or 4 meters every 1 second, whereas Diego goes 5.5. How far did they move in each 1 second? We just said that there. All right, so we're going to skip that one. Look at this last one here, number 4. If Han ran 100 meters in 20 seconds at a constant speed, is his faster or slower, or the same as Lynn's or Diego's? Well, again, we're talking about 20 seconds to 100 meters. Divide both of those by 10, we get 2 seconds for every 10 meters, or 1 second for every 5 meters. So, is he faster, or slower, or the same as Lynn? He's actually faster, right? Because in 1 second he goes 5 meters, she goes 4 in 1 second. Diego goes 5.5 meters in 1 second, so he's slightly faster. Not much, but just slightly faster. But again, we have to get these to some sort of numbers where we can compare them easily. Because while Lynn and Diego is fairly easy to look at there, we could do the same thing here, and we could change this so that these are both 10. So this would be a 10 to 50, right? 10 seconds for 50 meters, because we're dividing by 2. So we can use any of those to look at to compare. We can also put it down to the 1, so we've got it there to compare as well. The big point here is that when you're looking at speeds, comparing speeds, you're looking at distance and time. The more distance in a period of time, the faster it's moving. So knowing speed in meters per second in this situation, or any speed, time, distance to time, is going to be kind of like knowing unit price in dollars per item. If you know that singular part, it makes it a lot easier to figure it out in the total for a comparison. So that's it for today. Have a great one.